Hi, welcome to this complete chapter of Sequence and Series. Today we are going to learn every concept not by memorizing but by truly understanding how numbers create patterns. A sequence is simply numbers written in a particular order, and that order always follows a rule. Like here, every term increases by 3. Once you identify the rule, the whole sequence becomes predictable. Technically, a sequence is a function where the input is n and output is the nth term. This, this helps us find any term without writing the whole list. When we add the terms of a sequence, it becomes a series. Sequence means listing, series means adding. Now that we have covered the definitions and seen examples, let's use this table to permanently cement the difference between these two concepts. Look at the first row, the fundamental concept. A sequence is the list, it is the set of numbers themselves. A series is the sums. It is the operation of adding them together. This difference is clearly reflected in the notation. When you see a sequence, you see commas separating the terms A1, A2, and so on. The result is a list. When you see a series, you see plus signs and the sigma symbol, telling you to add. The result is a single value. A progression is a sequence that follows a formula. And in maths, we mainly study three types of progressions: arithmetic progression AP, geometric progression GP, and harmonic progression HP. Let's understand each one clearly. First is the arithmetic progression AP. In an AP, we simply add a fixed number to get from one term to the next. This fixed number is called the common difference, denoted by D. The formula for the nth term is an is equal to a plus n minus 1 d, because d is added n minus 1 times, and the sum of n term is Sn is equal to n by 2 to a plus n minus 1 d. Let's look at an easy example. Sequence 3, 7, 11, 15 dash dash. Here the first term a is equal to 3 and the common difference is equal to 4. To find the seventh term, we just add 4 into 6 times. So a7, seventh term is equal to 27. Now for a slightly tougher one. Here third term is equal to 7 and seventh term is equal to 15. So a plus 2d is equal to 7 and a plus 6d is equal to 15. Solving this, we get a is equal to 3 and d is equal to 2. Therefore, the 10th term a10 is equal to 21. Next, we have the geometric progression or GP. Instead of adding in GP, we multiply by a fixed non-zero number to get the next term. This fixed number is the common ratio denoted by R. The formula for the nth term is an is equal to ar to the power n minus 1, because a multiplied by r n minus 1 times, and sum of n terms is Sn is equal to this. Now, infinite GP. This is special. It only exists when the ratio r is between minus 1 and 1, because n becomes large, r to the power n becomes extremely small, almost 0. That's why an infinite GP with mod r is less than 1 converges and the sum becomes a by 1 minus r. An easy example is the sequence 2, 6, 18. The first term is 2, r is equal to 6 by 2, that is 3. So the fifth term would be 162. Similarly, we solved example 2. Finally, the harmonic progression or HP. This is defined indirectly. A sequence in a HP, if the reciprocals of its term form an AP, there is no simple formula for the sum of an HP. An easy example of an HP is 1 by 2, 1 by 4, 1 by 6. The reciprocals are 2, 4, 6, which clearly form an AP with a common difference is equal to 2. So 8 term of an AP is equal to 16, implies that 8 term of an HP is equal to 1 by 16. For a challenging example, find the 8 term of the HP 6, 3, 2 dash dash. First take the reciprocals to form the AP, that is 1 by 6, 1 by 3, 1 by 2 and so on. Then find the common difference. D is equal to 1 by 6 we get. The 8 term of an AP is equal to 4 by 3. After solving we get. Therefore, the 8th term of the HP is the reciprocal, which is 3 by 4. Now, let's move on to the means AM, GM, and HM. Focusing on any two positive numbers a and b, the arithmetic mean is the simple average. Am is equal to a plus b by 2. The geometric mean is the square root of the product. Gm is equal to under root ab. The harmonic mean is the reciprocal of the average of reciprocals. That is hm is equal to 2ab by a plus b. The most important concept when dealing with these means is their fundamental inequality relationship. Am is always greater than or equal to Gm, which is always greater than or equal to Hm. A slightly tougher application, we can also show that the square of the Gm equals the product of the Am and Hm. That is, Gm square is equal to Am into Hm. Let's take two easy numbers, A is equal to 2 and B is equal to 8. Implies that Am is equal to 5, Gm is equal to 4, Hm is equal to 3.2. Notice that Am is greater than Gm is greater than Hm. The relationship holds true. Using our previous value, Gm square is equal to 16, Am into Hm is equal to also 16. This confirms the powerful relationship between the three means. Now it's time to test your understanding and creativity with a few tough questions covering the whole chapter. Pause the video and try to solve these questions by yourself. Solutions. First, convert the HP to its corresponding AP. Implies that Q 1 by Q is equal to A plus P minus 1D and 1 by P is equal to A plus Q minus 1D. By solving these two equations, we get D is equal to 1 by PQ and A is equal to 1 by PQ. So PQth term of AP is equal to 1 implies that HP PQth term is also equal to 1. Second, use the formula for the sum of an infinite GP. S infinity is equal to A by 1 minus R. That is equal to 15. Then sum of the squares of terms form a new GP, that is a square r to the power 4. Implies that a first term is equal to a square and common ratio is equal to r square. So solving both these equations, we will get r is equal to 2 by 3 and a is equal to 5. So the series is 5, 10 by 3, 20 by 9, so on, and fifth term is 80 by 81. Since A, B, C are positive, we can apply the AM is greater than or equal to GM inequality to three pairs of variables. Apply to the pair AB, we get A plus B is greater than or equal to 2 root AB. Second, apply to the pair BC. Third, apply to the pair CA. Since A, B, C are positive, all terms are positive. We can multiply all three inequalities without any sign change. After this, we get A plus B into B plus C into C plus A is greater than or equal to A, 8 into A into B into C. This completes the proof. Excellent. You have successfully navigated the world of sequence and series. If you found this helpful, make sure to hit that like button, subscribe and follow my page Mathology for more detailed breakdowns and simple, clear explanations of complex math concepts.